I did try to make this study guide as similar as possible to the actual CQA. So question number 1 on the study guide is very similar to question number 1 on the test. So it goes in the same order. Okay, it is not the exact same question, but it's very, very similar. So when you have these word problems, make sure you read it fully once and then go back through and identify your important information. So a long-distance phone company charges $25 a month plus 3 cents per minute for calls. If a family's total monthly bill is $58.55, which has $31 included for internet, how many minutes did they use? All right, so again, the total bill was $58.55. So the first thing that we want to do is we want to take off the 2 charges that we know. We know that the charge, you have like the base charge of $25, and then you also have the charge of $31 for internet. So what I did was I did $25 plus $31, and that gave me $56. And I subtracted that from my total, $58.55. And that gave me $2.55. $2.55 is how much was spent on those, per minutes, okay? Because we use 3 cents per minute. So we're going to take that $2.55 and divide it by that 3 cents. Now when we're dividing by decimals, we want to get rid of this decimal out here. So if I get rid of that decimal out here, I need to move the decimal 2 places. So if I move this one 2 places, now that becomes a 255. So it's going to be 255 divided by 3. And now it's just a long division problem. 3 goes into 25 8 times. Whoa. One left over. Bring down your 5. 3 goes into 15 5 times. And there is not a remainder. So you are finished. So that 85 represents how many minutes? So your final answer is 85 minutes. I would not count it wrong if you didn't put minutes, no. So any questions about number 1? Yes. Can you make it into an hour and 25 minutes? Yes, that would be the same thing. That'd be fine. Yes, there would be other methods of doing it. As long as you got the same answer I did, then you know you did it correctly. Okay, let's move on to number 2 then. So number 2 is also a word problem. It says, Sammy usually uses her brownie recipe to make 24 brownies, but this time she wants to make 48 brownies. So I don't know about you, but when I read that first sentence, I thought, oh, if it normally makes 24 and she wants to make 48, that's twice as much, correct? Okay. The recipe calls for 2 3/4 cups of sugar, and Sammy has 4 cups on hand. How much more sugar does she need? Well, if she's doubling this, then we need 2 3/4 plus 2 3/4. Okay, because she's making 2 batches of this recipe. Now you could do 2 3/4 times 2 if you wanted to also, but I think this is easier. So that's going to give me 4 and 6/8, which would be 4 and... Sorry. I was like, wait a second. Thank you. Like, that's not right. Add your numerators only. That's like fractions 101 right there. Sorry about that. Alright, so 3 plus 3 gives you that 6. You keep your denominator. Now 6/4 is 1 2/4, which is the same as 1 1/2. Okay? So we need to add that 4 with your 1 1/2, and that's going to give you 5 1/2 total. Okay, that's not my answer though. It's not my answer. Because it wants to know how much more sugar she needs. It says that she has 4 cups on hand, meaning she has it in her cabinet or wherever. Alright? So if she needs 5 1/2 cups total for the recipes, and she has 4 cups already, that means she needs another 1 1/2 cups. And that is your final answer. All right, questions about this one? So question number 3. Question number 3 is one of them that is worth multiple points because it has 2 parts. So it gives you the heights of the 5 starting players for the Indiana Pacers. And it says what are the total heights and then what is the average height. All right, so we have 5 mixed numbers. My suggestion is to first just go ahead and add your whole numbers. All right, and I'm going to do this actually down here so I have space. So we have 80, 81, 79, 82, and 83. So no calculators tomorrow. We want to make sure that we're really adding carefully. So that gives me 10, 12, 15. Carry my 1. I noticed that when I was doing this that I could group this 1 with my 7 and make that an 8. And then I'd have 1, 2, 3, 4, 5, 8s. And so that gave me a 40. All right, so once we have added our whole numbers, we can add our fractions. Now, some of these fractions have different denominators. So if I'm looking at the denominators, 8, 2, 8, 4, and 4, a common denominator of all of them, we can make all of them into denominators of 8. So we have 5/8. Now 1/2 would be the same as 4/8. We have 7/8. We have 1/4, which is the same as 2/8. And 3/4, which is the same as 6/8. So I'm going to add up all these fractions. My denominator stays an 8. So I'm just adding my numerators. So 5 plus 4 is 9. That'd be 16, 18, 24. And 24 over 8 is the same thing as 3. So I'm going to take that 3 and add it on to this 405 I have over here to give me a grand total of 408 inches. So that would be my total of the heights. All right, part B. What is the average height? Write your answer in simplest form. So how do we find an average? Tommy? Total? So 408 divided by 5? Yes. 408 divided by 5. I'm going to switch colors because this, again, is for part B. Okay. 408 divided by 5. 5 goes into 40 8 times. Nothing left over. Bring down your 8. 5 goes into 8 one time with 3 left over. So if I was going to write my final answer as a fraction, my whole number would be the 81. My remainder is my numerator, and my denominator was a 5. 81 and 3/5. That would be the average height. If you're someone that just really hates fractions, but you're good at turning them into decimals, you could change everything into decimals, and that would be fine. I will accept your answer in decimal form. Question, Tommy. All right, so that's your other option, right? Is when you have done this and you get 81 is what, 405? And you get 3 left. To put a decimal here and bring down a 0, 5 goes into 36 times. So saying 81.6, that is the same thing. That's fine. That is fine. I will accept that answer. Okay? Any other questions? These have been good questions so far. All right, let's look at question number 4 then. Some of you remembered seeing a question like this on the test that we had mid-quarter. And it wants you to estimate, so that's an important part of this. Estimate the value of -3 times pi to the second power. Now, usually for pi, we use the number 3.14. But since we're estimating and since we're going to use an exponent, we're just going to use the 3 only, okay? So we're going to estimate negative 3 times 3 to the second power. So again, I'm replacing pi with a 3. I want to do my exponent first. 3 to the second power is 9. And negative 3 times 9 is negative 27. Any questions about that one? I see some people writing, so I'm going to give them a second. The answer would be negative 27. And now this is going to be, this one is a multiple choice answer on the test, so that'll probably make it a little bit easier for you, okay? But pi is going to be in there, so just keep in mind that you just want to use the 3 for pi. Okay? Alright, let's look at question number 5. Question number 5 says identify the largest number. So when we do that, we need to first estimate the value of each one of these numbers. Now 30 this is not a perfect square, but we need to think about which 2 perfect squares does it come in between. You all know? Can you help me out? Well, square root of 25 and the square root of 36, right? So those are the 2 perfect squares that it comes in between. And this equals 5 and this equals 6. So we could estimate this to be about 5.5. Okay? Not exact, but between the 2, 5.5. The next one, 4 times pi. Well, again, we know that pi is 3.14, but let's just estimate it as being just a 3 again. So 4 times 3 is 12. Over here, if I took off all of those decimals, I could just say this is 6. Because again, I'm just looking for the largest number, and I know 12 is bigger than 6, no matter how many decimal places it has. And then the last one over there is probably the one that was the most difficult for people yesterday when they were working. Again, thinking about what 2 perfect squares the square root of 5 comes in between. It comes in between the square root of 4 and the square root of 9. Okay? It's pretty close to that 4 though, so I'm just going to say, alright, it's about 2. So this would be 2 times that, which is 4. Even if you would have said it was a 3, 2 times 3 is 6, so it's still not getting anywhere close to your answer, which is this one right there. 4 times pi is by far the biggest one here. Questions on this one? Okay. Question number, is this 6? I can't see. 6, yes. Place each number on the number line. Alright, so we have a negative. So whenever you have negatives, that means it's going to be to the left of the 0. Negative 0.25 is going to be really close to that 0. Make sure that you put a point on the number line and you also label it. Okay? The square root of 3, again, we need to estimate the square root of 3. That's really close to the square root of 4, isn't it? And the square root of 4 equals 2. So that means it's just going to be a little bit less than 2. There we go. 3.5 repeating. Just pretend it's 3.5, so halfway between 3 and 4. And 5 over 2. Now if you have an improper fraction, go ahead and change it into a mixed number. 2 goes into 5 twice with 1 left over. So 2.5, that's halfway between 2 and 3. Alright, any questions on those? Okay, we'll look at number 7 then. Alright, number 7, we're starting our scientific notation problems. So this one is an addition problem, so you're going to have to remember that we had a lot of different rules for these problems. The addition problems were the ones where we needed to have our exponents the same. So I'm going to change my exponent of 9 to an 8, and by doing that I have to subtract 1. So I'm going to move this decimal over 1. So I'm going to rewrite this as 45 times 10 to the 8th power. Okay. Now I want to add 3.4 plus 45. So again, adding these up, make sure you're lining up your decimals here. And you get 48.4. So 48.4 times 10 to the 8th power. We keep that 10 to the 8th power, that's what they have in common. But this is not in correct scientific notation. We have to move this decimal over 1. So I'm going to add 1 to my exponent. So final answer is 4.84 times 10 to the 9th power. And I'm going to pause it just to make sure everyone has this written down. All right, our next problem, number 8. Amazon.com averages 6.2 times 10 to the 6th visits each day. How many visits does the website get in 3.6 times 10 to the 2nd days? So, do we need to multiply or do we need to divide? We need to multiply. Because if I said there were 5 visits each day and there were 30 days, you would do 5 times 30, okay? So sometimes just putting in easier numbers for things lets you know like what if you need to multiply or divide, all right? So again, we're going to multiply. So 6.2 times 10 to the 6th power times 3.6 times 10 to the 2nd power. Now when we're multiplying and dividing in scientific notation, we do not need the same exponents, so just leave them the way they are. First thing that I'm going to do is multiply 6.2 times 3.6. So hopefully what we've been doing in math review will help you with this practice here. This is just like 62 times 36. So I'm going to go ahead and do that real quick. I have 2 digits after my decimal. Don't just drop it down. 2 digits after my decimal, so it goes in between my 2 and my 3. So I get 22.32 times 10 to the, and when you're multiplying, that's your product of powers property. When you're multiplying, you're going to add your 2 exponents together. So we're going to do 6 plus 2 is 8. Now this is not incorrect scientific notation, so we need to move the decimal 1 place over to the left. So I'm going to add 1 to my exponent, making this final answer 2.232 times 10 to the 9th power. We'll pause the video. So we're going to move on to number 9. So in number 9, you can see it has 2 parts. That means it's going to be worth more than 1 point. It says object A weighs 4.92 times 10 to the 7th milligrams. Object B weighs 3 times 10 to the 4th milligrams. How many times bigger is object A than object B? How many times bigger? We did problems like that. How many times bigger is this or that on those word problems? And those are your dividing problems. So you need to take, it says show the initial setup, first step for solving the problem. That is where you would show that you were dividing those 2 numbers. That's what all they were wanting in part A, was that you were showing that you were going to divide. Part B is where you're actually solving it, writing your final answer. So when we divide in scientific notation, we need to first divide our first 2 factors. So 4.92 divided by 3. 3 goes into 4 1 time. 1 left over. Bring down your 9. 3 goes into 19 6 times. 6 times 3 is 18. 1 left over. Bring down your 2. 3 goes into 12 4 times. And we would have nothing left over. Do not forget this decimal right here between your 4 and the 9 goes straight up into your answer. So 1.64 is the first part of our answer, times 10. And then looking at your exponents, you have a 7 and a 4. So when you're dividing, the rule is the quotient of powers property is to subtract those exponents. 7 minus 4 is 3. And there it is. Okay? So number 10 says simplify. Now I think at first when you look at this problem it's like, whoa, that looks really confusing. Simplify that for n equals 2. So what they want you to do is put in a 2 for any place you see an n. So I'm just going to rewrite this first. Okay. Then parentheses. Alright, now we have to deal with these exponents. So, something to the 0 power. We talked about it when you had something to the 0 power. It equals 1. So again, anything to the 0 power equals 1. So 1 minus 2 to the negative third power. Now, 2 to the negative third power. If you remember, we said that I'm going to do this kind of over here, that you could rewrite this, and if you move the power to the denominator, then your exponent becomes positive. Do you remember talking about that? It's been a couple weeks ago. So again, if you have a negative exponent, you want to move it to the denominator position so that it becomes a positive. And now we can work this out. 2 to the third power, well that means 2 times 2 times 2, which is 8, correct? So 2 to the negative third power is 1/8. So I have 1 minus 1/8, which is what? What's 1 minus 1/8? Why would it be negative? I have a whole minus 1/8. I would have 7/8. That would be 8/8 minus 1/8, which is 7/8. There we go. Making a mistake that sometimes you all make, right? Missing something little like that, which becomes a really major thing. So you're right. This says times right here. This needs to be times. Thank you. Thank you. Thank you. So over here, we are doing 1 times 1/8, aren't we? Oh, man. I'm glad that you pointed that out because I guess, did no one else realize that I made that mistake? Oh. Thank you. Because what's bad about that, and that's the kind of mistakes that sometimes you all make, like you do all the hard parts correctly and then you mess up something like that, right? It's frustrating. So it's a perfect example. Like, I mean, I make those mistakes too. It happens. All right, let's look at our last one. Number 11. Select all that are equivalent to 6 to the negative third times 6 to the 7th. So when you have the bases are the same, what are you doing when you're multiplying? Keeping the base and adding the exponents. So negative 3 plus 7 would be to the 4th. So obviously this one. Are there any others up here that are correct? No, there's not. This one, I can see people doing 6 times 6 is 36. So that's, you don't want to ever multiply your bases, so don't do that. This one here, that's just, they did 3 plus 7 instead of negative 3 plus 7. This one, I don't know what they did on that one. How they, well, they did 6 times 6, but I don't know how they got the 1. This one, they multiplied the exponents. That's not right. And that one down there, just 36? No. So, the only one that is, it says select all, and usually when it says select all, they usually almost always mean more than one. But this one, there's only one correct choice. I don't want to tell you that. We do have, well, right. So it says a student simplified that problem. Explain the error the student made. Use words and numbers to explain. So they kept the base, right? That's correct. What are you supposed to do with your exponents when you're dividing? You subtract them. So what they should have done is kept their base, and then they should have done 8 minus 4, which is 4. But they got a 2. Now they had parentheses around this. They had a 2. How do you think they got that 2? Daphne? They did 8 divided by 4. They divided their exponents. Addison, go ahead and go. Instead of subtracting them. So you want to specifically say what they did wrong. So in this one, they divided their exponents instead of subtracting them. What is the correct answer when you simplify? Make sure, why do they have those parentheses around? Is that important, the parentheses? Yes, it is. Because it's -5 times -5 times -5 times -5. If you didn't have the parentheses there, then it would be a negative 5 times 5 times 5 times 5, which is different. Okay? So make sure you keep those parentheses in there if you have them. That's the last one, right? Yeah. Okay, that makes sense.